Hello everyone, I'm Zhang Qingfen, a lecturer from the Smart Medical Bioinformatics Master Degree Program of Department of Biomedical Engineering, Iso University. Today, I would like to introduce the VR teaching material we developed. The VR teaching material focuses on the prevention of infectious disease. Does anyone know why we select this down? In the past 3 years, the COVID-19 pandemic has greatly influenced our life. It has had considerable effects on economy, society, and even on our lifestyle and teaching method. As anyone can see here, by this November, over 7 million COVID-19 cases has been reported in Taiwan, accounting for over 12,000 deaths. Therefore, the prevention of infectious disease is crucial. In the prevention of infectious disease, primary screening is the fundamental measure for disease detection. Primary screening requires considerable human resources. Fortunately, Iso University has the Department of Medical Laboratory Science, and Ida Hospital contains the Department of Laboratory Medicine. They play a critical role in the cultivation of medical personnel for infectious disease screening. Ensuring the safety of screening training is vital to the cultivation of medical personnel for infectious disease screening. Accordingly, we considered how to develop a safe, convenient, intuitive, and repeatable method for the training of screening personnel by using VR. Why did we choose to use VR? VR teaching material can be applied to create an immersive virtual environment. We developed a VR environment record using 360-degree camera. In medical training, authenticity is very important. Many training environments, such as that for sample screening, requires large-scale equipment unavailable on campus but accessible in hospital. However, we cannot transport students to hospital for the in-person, individual, close contact, and repeated operations of this equipment. Considering both the environmental constraints and infection risk, we select VR to achieve effective training, thereby providing students with a safe environment in which they could repeatedly engage in practice operation. This enables students to familiarize themselves with the testing process for future operation. There is another reason why we used VR, namely its suitability for 360-degree video recording. Specifically, 360-degree video recording can be easily expanded to our fields. In the development process of our teaching plan, faculty from the other departments, including the Department of Nutrition and Department from the College of Language Arts, were inspired by its versatility and started using VR to develop teaching plan. As everyone knows, the caregiving process of nursing personnel involves various scenarios and implications. The use of VR-based teaching material can provide students with an immersive experience to support their training. The use of VR, as we have demonstrated, can be easily adopted by other departments. So how did we develop this teaching project? We used Vertex as a platform. The platform was used to edit 360-degree videos to emphasize the focus of teaching plans and enhance student engagement. We divided to the development of the teaching plans into 3 stages. In the first stage, we clarified how to operate the captured recording using the 360 degrees camera and how to edit the captured 360 degrees video recordings. When we had a better-based understanding of the equipment, we discussed how to edit the video to create a scenario. The scenario was based on narrative that supported the training of students. After understanding, discussing, and setting the scenario, we confirmed the editing script. After completing the first stage and confirming the script of the scenario narrative, we start planning the video. The records used for the VR teaching material were captured in the hospital during an on-site visit. In the second stage, we selected actors and held rehearsals of in-person demonstration. Specifically, we invited the hospital clinical scientists to perform demonstrations for us. Because human error may occur during video recording, rehearsals were conducted and everything was set up before the official recording. We used the video recordings to create the 360 degrees video. We then decided on where to insert hints and questions in the video. In the third stage, when the overall teaching plan was completed, it was uploaded to our cloud platform for faculty members to use. Student engagement data was analyzed through the virtual platform, and the results we used to determine students' use and learning outcomes. Through this production process, we developed our teaching project. Let's take a look at the teaching project. The project focused on the disease screening process and assists students in understanding the overall process, which consists of rigorous standard operating procedures of SOPs. We divided the screening process into 5 steps, namely sample retrieval, personal protection, sample preparation, sample testing, and post-test handling. Each step requires different precautions. Because the testing sample is various sample, negligence during any step may result in disease infection and may cause the virus to spread beyond the hospital environment and result in community infection. Therefore, every step of virus screening process is critical and interlinked. Let's review the precautions of each step. These precautions are the key points of the video recording used for the VR teaching material. The VR-based teaching plan is divided into these 5 steps. Later, I will demonstrate the sample preparation step in a biology safety cabinet. Let us first review the precautions of each step. In the sample retrieval step, we must first confirm whether the sample retrieved for the testing is correct sample. Then we must inspect whether the sample packaging meets the standard to prevent leakage and unspecific labeling. Finally, we must match the sample retrieved with the list of samples for testing to determine whether the sample data conform to or match the sampling list. If discrepancies are found, the sample must return it to unit it was sent from. If the packaging information is correct, the sample packaging is cleaned to sterilized before being placed into the collection box. Afterwards, the sample is subjected to testing. The personal protection of testing personnel is crucial. Testing personnel are required to wear a complete set of personal protective equipment or PPE, which must include a mask, a protective suit, and gloves. Each step has its own SOP, which are further detailed in our video. The key focus to maintain the airtightness of the PPE. No opening must be present. Such opening may lead to testing personnel becoming exposed to the viruses, causing infection. Therefore, personal protection is essential. Next, after completing the personal protection step, we continue to the sample preparation step. In this step, the sample is not directly placed into the qPCR machine for testing but must first be opened in a biology safety cabinet. This cabinet is crucial function. Specifically, the outgoing air of the cabinet is subjected to HEPA filtration to ensure that the versus sample does not leak into the outside air. Among the procedures implemented in the cabinet, that of sample deactivation is crucial. Sample deactivation involves adding reagents into the sample container and directly to the sample to deactivate the sample. If spill occurs during the sample deactivation process, testing personnel must handle the situation with caution. The timely clean up the sterile reaction after spill to prevent infection spread is imperative. All these procedures are just for sample preparation alone. After sample preparation is completed, the sample must be transferred to the qPCR machine for testing, and testing personnel must change their PPE. The sample preparation step is both scrupulous and meticulous. After confirmation that the sample preparation step has been completed, the sample is transferred to the machines for automatic testing. These tests include nucleic acid testing, reverse transcript testing, and PCR testing, after which a sample testing report is produced. For the testing material, we record the overall machine's operation process to enhance student understanding of how sample testing is conducted in hospital environment. Finally, the sample testing report is reviewed. However, this does not conclude the sample screening process. We must fully clean and sterilize the screening environment. The testing personnel must remove their PPE, which cannot be directly disposed of in a trash bin. Instead, used PPE must sterilize before its disposal as medical waste. The disposal of PPE marks the end of the entire virus screening process in a hospital environment. Therefore, next we will. The previously mentioned operation steps performed in a biological safety cabinet are presented in a video demonstration. Through this video, we aim to clarify how the VR presentation of recorded teaching material can positively influence student impressions of the teaching content. The teaching material design process was divided into two parts. In the first part, a presentation and quiz were held to teach students about the overall screening process. After the students have primarily understood of the screening process, the quiz is conducted to consolidate their knowledge. In the second part, a VR scenario created using the video recording is introduced. Students can wear head-mounted displays to experience and understand how to prepare testing samples and how to handle contaminants through the video. In particular, students learned that throughout the entire screening process, people who are not involved in the screening process are prohibited from entering the screening environment. Testing personnel must remember to place the signs on the doors of the laboratory stating that the screening is being performed. In the presentation of our developed VR teaching material, we include these details in the teaching plan to remind students of the crucial action. Now, let's see our developed teaching project.
拆封作业注意事项。BSC 生物安全柜操作。使用震荡器 Vortex 将解体混合均匀。将 Lysis Buffer 裂解缓冲液加至大康试管中。将简体盖子松开，以方便操作。将简体加到大康试管和 Lysis Buffer 作用。Lysis Buffer 可裂解简体中的细胞及病毒，释放出核酸。外层手套需在 BSC 内脱去。 碱体不小心泼洒时，应将碱体盖住后，再用纱布盖住污染处，避免污染范围扩大。于污染处倒 0.06% 的漂白水。外层手套需在 BSC 内脱去，接着静待15分钟。离开检验室前需关上门，并贴上污染告示的标志。等待15分钟后，检验室才能开放人员进入。将纱布拿起，丢至污染性垃圾袋内。使用 0.06% 的漂白水再擦拭一次。再使用75% 的酒精擦拭。记住，外层手套必须在 BSC 内脱去。